Welcome, this is where nerds come to learn things. If it's your first time here, click on the subscribe button and on the bell icon to get notifications about new videos. Thanks for watching, hope you enjoy it. What do we have? A very heavy piece of gear. It's a 8901B Modulation Analyzer. Apparently this has a fault. Apparently the display flickers. It uses a multiplex display. I've had a little look at the manual and just briefly tried to understand how it works. Okay, so I've got it standing on its face on the bench. When I put it down I can hear the buttons click. It's pushing all the buttons in, but it's in place, so I thought I'd just try and capture this on camera a bit better. I'm not going to cooperate it. I think I'm going to need pliers. Looks like it. Here we go. So here's the card. Alright, so with the device the right way up, it's supposed to read the voltage you want in that orientation. So here's the voltage you can have, depending on which way around you put it in. So that's 220 that way around. So 100 volts that way around. Flip it over, 230, 240 volt. Okay, so that's the one I want, it's 230 and 240 volt. So I'll put it back in that way, that should be the correct voltage setting. Push it back in. It's always very important to remember to do that when you get a piece of gear. I think that's right in. Fuse should also be replaced. Let's have a look. What's in here now? Current fuse is a 2.5 amp, 250 volt. 2.5 amp. What does it say what should be in here? It doesn't appear to be marked on the back here anywhere. It'll be in the manual. I'm after to look at the manual. But in theory I should halve that value to go to double the voltage. So I'm going to go and do that. Even 2.5 amps seems a bit high though. So I might chuck a 1 amp in there and see how that goes. So I had a quick look at the manual, and the manual says it should be a 1.5 amp fuse for 240 volts. Now I've only got a 2 amp or 1 amp, so I don't have anything between the two. Although I might even have some in a box somewhere amongst a whole bunch of other stuff, but I thought I'll chuck a 2 amp in for now. It's still slightly better than what was in there, so we'll go with that. And then we'll flip the thing around and we'll power it up. Ready? Oh. Oh. Don't know if you can see that display flickering. Can you see the display? It stopped flickering. It says on cow. All the indicators are on. Yeah, she ain't happy. Looks like power supply faults, so at least we know what to do with that. I will pull this thing apart and investigate what's going on there. But it does sound like a power supply problem. Sounds like the caps are gone. There's just no smoothing. It's like AC's coming straight through it or something like that. That's really what it sounds like. Which will play havoc with digital circuitry. It really doesn't like AC going through digital circuits. There we go. You can see it better. So all these lights are on. The lights here are all on. Yeah, so it's like trying to start but not. That's fine. I'm pretty sure this is power supply. Alright, so this is the HP8901B Modulation Analyzer, which I did a mailbag recently. Which live stream people currently haven't seen yet, because I'm doing this live stream as well. Digital side's looking okay. I can't hear a fan spinning, so that may also be part of the issue. So we'll get the back cover off this, and we'll see what we can get out of it. Right, let's get this cover off. I've taken all the screws out the top one. Well, it's a bit dusty. And that's the section we're actually interested in right there, that power supply. Yeah, it's had a bit of use. Certainly has had a bit of use. Right, well there's that card I was looking for, which is the regulator card with all the test points on there, the LEDs, and I can just see there, the lighting's probably hiding a little bit, but there's a LED right there which is lit up, which is marked 15 volts. Well, the test point next to it's my 15 volts, so that's good. So that LED's on at least, that's something. I'll get this other screw at the bottom cover, so we're ready to go with that one as well, because I only need to get to the other side. Okay. Oh, that's dusty. Yeah, that's a mess. Okay, let's just flip this over. Well, even the dust fell out. Look, clumps of dust fell out of it. Right in the back there. That is absolutely filthy. Yeah, look at that. That fan is absolutely rooted. That is full of fluff. Maybe that's what the buzzing is. My fan can't turn. Try and get a live stream, see if you guys can see it as well. I don't know if you can get to see that detail in there, but it's filthy in there. It's like it's never been apart. Is that, can I get that off there? I think I can. Let's take the fan off. Pull this out here before I touch something I shouldn't. Alright, so look. There's a screw missing. I'll get it out. Well, it looks like I say I'll get it out. Oh, look at that. You see how bad that is on the live stream? Wow, that's pretty bad. Wow, I don't think I've ever seen a fan that bad. Who knows, maybe the fan is knackered, maybe that's why it's full of fluff, because it's not turning properly. I purchased a bunch of fans recently, which will be in mailbag. That is pretty appalling, actually. Yeah, what if I can unplug that and take it away and clean it? Doesn't look like it. But I think they're different size. I've got them sitting over here actually, so look. Yeah, that ain't gonna fit. That's a shame. And I don't have the right fan to replace it if I need to. Alright, well, let's get the worst of this crap out of here. Alright, now it turns. Well, that is really going to need a good clean up. Alright, we won't go into that too much. Let's just plug power back in and you can see if that fan actually fires up or not. Oh, okay. Fan goes. It is knackered. Okay. That fan definitely needs replacing. Those bearings are shot. That is the worst one I've ever seen. It's interesting there's a screw missing in it. It's that dirty. I'll shove it back on for now and I'll sort that out later on. Don't need to see me do that. Well, that's impressively dirty, I have to say. Alright. Right, that is just awful. Right, this is why you should probably wear gloves when you're doing shit like this, actually. Right. Next thing. Let's do some testing, see what's actually going on here. Okay, so the scope's up and running. It's my Keysight scope, which you haven't seen me use on video yet. This is the one I won earlier in the year from Keysight. The DSOX1102G. That's on from the Testing Press contest from Wave. That Wave contest they did. It's normally called Scope Month. Initially they called it Wave and they did a slightly different format. And I was one of the winners for the videos entries. So, and that's what I won from that. So you would have seen that in the previous video if you've been subscribed for a little while. But it's the first time I actually used it in a video to do testing. Okay, so I don't have my ground clip on there yet. I probably should put it on. Since I'm going to be ground referenced. Well, I may be referenced, I'm not sure actually. It's 15 volt rail there. Nah, I need to reference, that's okay. So I'll do that. And that's the ground pin, just there. So the first pin there is plus 15 volts. Then we've got 15 volts switched. Yeah, that's what I need. Hold on. Yeah, there we go. So we get 14.6 volts there right now. And it's actually looking pretty clean. It's not too bad. Switch is currently off. Minus 15, nothing there. Plus 5, nothing there, obviously. Minus 5, nothing there. Plus 40, nothing there. Yeah. And that's because the thing's currently in standby. The only thing it should be on is that 15 volt rail. And that looks fine. Yeah, that looks right. So that supply rail at least looks okay. So let's power it up. And thinking this fan's gonna make a racket. Maybe I'll jam something in the fan to shut it up. I don't think making a racket. Alright, and we'll power it up and see what we get with these LEDs. Hopefully you can see the LEDs. They might not be a bit hard to see with these lights. Let's actually just shut some of those lights off. Make it a bit dark, but it makes it easier to see the LEDs. Right, here we go. Right, from what I can see from that, these three LEDs here are flickering, which is the minus 15, plus 5, minus 5. I think the plus 40 was okay. Let's try it again. Yeah, plus 40 came on after delay, and then it stayed on solid. So it's like those three supplies have got an issue, which means, from looking at the manual before, that probably a 15 volt rail or the minus 15 volt rail is what the issue is. Because that controls the other two supply rails. If one's playing up, the other two will play up. So let's just stick on there, minus 15. Oh yeah, look at that. That's pretty awful. Actually, is it quiet if I take the screwdriver out? Is it quiet or not? Yeah, barely. Alright. So, yeah, that should not be like that. Okay, let's check the other two rails. Yeah, that's noisy. So is that one, but they're at the same rate as that waveform there. So I'm pretty sure that means that's the minus 15 volt rail. Okay, that's cool. We'll look at the diagrams. Okay, so here's the service manual, and this is service sheet 31, which is page 198 in this 212 page manual of volume 2. There's 3 volumes. So volume 2 is a lot of the description about troubleshooting and stuff like that and diagnostics, and volume 3 contains a lot of circuit diagrams and extra information. So this tells you all about the power supplies in this particular section of the manual. Describes the usage. I've already read through all this stuff, well, most of it, just to try and get an idea of how it worked. I haven't read through every little detail, but one of the things I did pick out of this is this power supply dependency section here. Now this is very handy, right? Not all manuals have this, and it's great to see it in here because it does give you some great troubleshooting tools. It makes diagnostics a bit easier, can narrow down things much more quickly. Now, reason being that often power supplies are interdependent, so if one supply rail is faulty, it might affect other rails, and that's the case in this unit here as well. So we've got a plus 15 volt rail, as we saw, that's working okay. And that if that rail is faulty, it affects all the other power supplies, all the other rails. If the minus 15 volt rail is faulty, that affects the plus 5 volt and minus 5 volt rails. So it means these 3 rails will play up, and that's what we're seeing when we did that test. You can see those three LEDs flickering. And the fact that all 3 are flickering means it's likely to be the minus 15 volt rail which has got a problem, because if it's one of these, it's unlikely to backfeed. It could, if it's a short or something like that, it's possible, but not likely. So I believe it's that minus 15 volt rail. And also you've got independent supplies for the plus 5, minus 5 and plus 40 rail. Right? So the plus 40 looked rock solid, that looks okay. I don't believe there's an issue there. So the fact that those 3 rails there are flickering means I think it's the minus 15 volt rail which has got the problem. Right? The manual is actually very thorough. It goes through lots of testing, how to check everything, checking the rectifier diodes, the actual checking the individual rails as well, what they expect to see under certain conditions. It's very thorough, which is good. A lot of HP here doesn't actually have information on the power supply because the power supply is made by somebody else, and so there's no circuit diagrams, no diagnostic information apart from these are the voltages you should be getting. So it's good to actually see it all in here because it makes this job a lot easier. Okay, so let's look at the actual diagram. So we've got main diagram here, which is obviously the, well, obvious until I explain it. This section here, which is in the dotted line, which I'll blow up in a second, that's this board, and this section over here is this board here. So that's the main rectification and smoothing PCB, and this is the voltage regulator PCB, as we were testing on just now with the test points on the top of the board there with the LEDs. Alright, so zoom in here. So these are the unfiltered or unregulated outputs. They feed the regulator, so it's plus 40 there, minus 5, plus 5, minus 15, and plus 15 here. Okay. So if you look at the actual setups on these, you've got a standard bridge rectifier here, which is doing the plus and minus 5 volt rails. So if one rail has got a fault, the other one could have as well. Could be interrelated. I mean, but things, bridge rectifiers, if you get one diode goes out of a rectifier, they can affect one rail even though they share a source, that sort of thing. Or they can drag the other one down and, dial dependencies. And also got the minus 15, plus 15 here sharing the same rectifier as well. Now because the plus 15 looks fine, it's unlikely to be a fault with the supply or this over voltage protection, because it would be affecting that plus 15 volt rail as well, most likely. It's also unlikely to be the bridge rectifier, but it could still be. Don't forget, the positive rail is only using 2 of the diodes, negative rail is using the other 2 diodes, right? So this, that one's positive, that one's positive, that one's negative rail, that one's negative rail. So it could be one of those CR4, CR7 having a fault. I don't think so. I think it's more likely to be C7. 5800 UF capacitor just there. That's what I believe the fault will be, was this part. Ignore I5, that's just a discharge resistor, so it drains a capacitor when it's powered off. Just a safety feature. A lot of things have it, you just ignore that. In reality, it doesn't really matter if it's there or not unless you're actually touching things. It's just a nice feature to have in there. Now, and over here, if you go across this regulator board, it's actually across 3 circuit diagrams, I think 2 or 3 pages. It's broken down to each regulator section. So you've got the plus and minus 15 volt rail in here, so there's plus there, minus there, and these are the pass transistors. Now this A29 is marked as here, and up here, zoom out slightly, a little bit big. Alright, so these both, that's A29, this is an A29 as well. That's actually a big heatsink on the back of the unit, and it's got 4 pass transistors on it, so there's 1 for each power supply. So it just plugs in and goes through that and comes back, basically. Right, so this section here is purely 15 volt rails, and then you've got other pages for the plus and minus 15 volt rails and the 40 volt rail. Right. So the fact we're getting plus 15 means it's fine. Plus 15 works, minus 15 doesn't, it seems. So that's what I'm going to look as minus 15. I think that's what the fault is, because of those dependencies on the minus 5 volt and plus 5 volt rails. So I'm going to look here, C7. So let's bring this down. C7 is on the main board, and that is right there. There's C7 right there. So that's the capacitor I'm really suspicious of. So what we'll do is we use a scope and we'll check all the capacitors and just see what waveforms we're getting on the base of the capacitors. These are all bolt-on types, so we'll just probe them and see what we're getting on each one. See if there's any ripple. Alright, so I've got the scope fired up, and we'll check the main power supply board down here. This is all the pre-regulation stuff, right? So it's before the regulators. This is purely the capacitor smoothing and things like that, the original filtering. So there's screw terminals here, pair there, there's a pair there, a pair there, and a pair here. Those are all those big 4 capacitors which are on that board. So they're all screw type mounting rather than solder mounting. And it's all marked on the bottom here what they all are too. So that says minus 15 volt, sorry, plus 15 volt there, minus 15 volt there, plus 5, minus 5. So I'll test each one and we'll see what the scope says about how noisy it will are. So we'll start at plus 15, which looks like it's okay. Yep, that looks alright. It's a little bit of spurious noise on that waveform, but that's probably just induced noise from my setup here. You can see I've got 50 Hz noise just locally, right? So it's not surprising. Now let's see the plus 5 volt. Yeah, that looks okay. Nothing too bad in here. Minus 5 volt. Yeah, that looks alright. This is without the power unit powered on, right? So it should be a bit quieter as well. When it's in standby, the thing is still powered up on this board here, so I don't actually need to be turned on for this. And minus 15 volt. Oh, there we go. Look at that. That's a real mess. That's 100 Hz waveform in there. So that capacitor there isn't working at all. That's what's wrong. So that's the 0 volt rail right there, and that's the capacitor output, by the positive. Well, yeah, the negative of that capacitor is negative rail. So yeah, that shouldn't be like that. That should be more like this one. You know, just low voltage. So that capacitor is completely dead. And if I power it up at the same time, let's do this. It's even worse. Yeah, so definitely bad capacitor. So I fit the capacitor here across these two terminals on that capacitor. Right, it's just a temporary fix just to see if I can actually get any life out of this regulator circuit. So as you saw before, the waveform was awful, and I need to see if I can get that waveform smoothed out and see if it makes the unit behave. So that's the first thing there. So let's plug the power back in. Right, let's probe this thing. Let's see what we're actually getting. So back on the same point, just there. That's much better. Look at that. Okay, all the noise is gone. So yeah, that capacitor there is definitely a fail. Alright, well let's spin this thing around and we'll power it up and see what it actually looks like. See if anything's changed. The problem with a big gear like this is that they're not necessarily the easiest thing to work on as far as fitting them into the frame and just manhandling the things. Right, ready? Let's try it. Fingers crossed that's the only fault. I really hope so. All the flickering's gone away. The buzzing's the fan because I've got it locked up. Oh, got some lights flickering over here. I'm guessing it's doing a self-test when it starts up. Lots of bits of test gear do. So we'll see if it... Yeah, oh, look at that. Look at that. I think that's working. How the hell do you use this thing? Wave power? Yeah, okay. That looks like it's going to work. So just like now I've got to do is sort the fan out. I need to inject a signal into it. I need to do that to test it properly, but at least the original fault is now gone. Alright, so I'm going to powder my cone. I've got it hooked up to the back of the modulation analyzer. So I'll fire this up and shove a signal into the HP, and we'll see what we get. Now I'm going to shove in a high enough voltage level, high enough signal so I should be able to see it. So let's just go as high as I can with 30% AM modulation. That'll be a good enough test, I reckon. I don't know if I can even see it on camera, but anyway, that's what we'll do. Right, moment of truth. Fire it up and see if it actually receives a signal. Really got to replace that fan. Hey, look at that, it's receiving it. It's off frequency, but it's receiving it. Okay, that's a good sign. It receives a frequency. Power. It's receiving something. Yeah, I'm doing millivolts, not watts, because obviously watts isn't quite the same thing, because that's a signal generator. Or the receiver. Right, so it's receiving something there. Let's just drop the levels down and see what we actually get. Yeah, so drop the level down, it correspondingly changed. Well, it changed as well. I have to actually figure out how to use this bloody thing. AM modulation. I'll probably got my signal level down too much now. So I've got it set at 30% and it's pretty much agreeing. So it looks like it's working. Let's just increase the modulation level to say 90%. And there we go. They agree. So at least it looks like it works. Okay, let's try it in frequency. I don't leave it on too long because obviously the fan's not going. Carrier frequency is to 1 gigahertz. And yep, there we go. It's doing gigahertz. And 1 megahertz. Go right down the other end. What does it cover? 150 kilohertz. So yep, there we go. It does it. She's working.